Let's have a look at one example. Though here we have the company Matrix Manufacturing. And this company, Matrix Manufacturing, is looking for a new location for its warehouse. The company has 4 customers. The customers are placed in Cleveland, Columbus, Cincinnati, Dayton. So Cleveland is here, Columbus is here on the map, Dayton is here on the map, and Cincinnati is here on the map. You see the coordinates are given for each location. And we also have the load that these 4 cities, the stores in these 4 cities require every day. 15 for Cleveland, 10 for Columbus, 12 for Cincinnati, and Dayton requires 4 units. Now the management pre-selected 2 potential locations for the future warehouse. These potential locations are in Mansfield with the given coordinates and in Springfield. Now the idea is to apply the load distance model to decide which of the locations, Mansfield or Springfield, is the better location for the new warehouse. What do we need to do? First of all, we need to measure the distances. We have to measure the distances from Springfield to Dayton, Cincinnati, Columbus, and Cleveland. And we have to measure the locations from Mansfield to Cleveland, Columbus, Cincinnati, and Dayton. The second step would be to identify the loads. In this example, the loads are already given. These are the loads that need to be transported to the 4 different stores. Then we calculate the score and decide between Mansfield and Springfield who should get the warehouse. Okay, how are, for step 1, the distances measured? Now these are our 4 stores, the existing stores, and this table shows you the distance to Springfield. Let's say the second part, the y coordinate and the x coordinate that are subtracted are always the same because these are the coordinates for Springfield. So now we know that the distance between Cleveland and Springfield is 20.5 miles. The distance between Dayton and Springfield is 3.5. Of course, it goes without saying that I now again use the rectilinear distance measure. Let's have a look again on the map and compare Dayton to Springfield and Cleveland to Springfield. So here's Springfield. Springfield is quite close to Dayton and quite far away to Cleveland, though this simple plausibility check gives us a good idea that these numbers are calculated correctly. We have to repeat this exercise for the potential location of Mansfield. Again, the coordinates that are subtracted are the coordinates of Mansfield, and now we have the distances to the other cities. Step number 2, we identify the loads. Though Cleveland needs 15 units, Columbus 10, Cincinnati 12, Dayton 4, and these numbers have been given in the text of the exercise. We did not calculate them, they were already given in the text. The final step is now to calculate the load distance value, and we have to calculate this for Springfield and for Mansfield, though we do this exercise 2 times. In the upper table, we calculate the load distance score for Springfield, and in the lower table, we calculate it for Mansfield. We just take the load of the 4 cities and we take the distance that we have calculated in step number 1 and we multiply both. So 15 times 20.5 is 307.5. 4 times 3.5 equals 14. So we have a load distance score for each of the existing customers, and we sum up the load distance score for all 4 existing locations. That means the load distance score for Springfield is 456.5, and we repeat the same exercise for Mansfield. Mansfield has a higher load distance score, and now recall that the idea was to do a weighting of distances and transported loads to evaluate each potential location of a warehouse. So we choose the location that got the lowest score. So in that case, Springfield would be the recommended location to choose. If you compare this to the factor method, of course, for the load distance model, we really have to take into account the load and the transportation distance. Yeah, the transportation distance is the main factor. We did not take into account any other of the qualitative factors. So maybe to make really a final management decision which location it should be, it makes sense to combine the load distance model with the factor rating approach to get a more comprehensive view of the problem. Let's have a look at a third method to make location decisions.